In the previous lesson, we learned how to run Kafka-Connect in standalone mode, which is great for development and testing. In this lesson, we are moving to distributed mode, which is the deployment model you would typically use in production. Distributed mode allows multiple Kafka-Connect workers to work together as a cluster. This gives you higher availability, automatic load balancing, and the ability to continue running even if one of the workers fails. This diagram shows the overall architecture of a distributed Kafka Connect cluster. Instead of having a single standalone worker, we now have multiple workers connecting to the same Kafka cluster. These workers don't communicate directly with each other. Instead, they coordinate through Kafka itself using several internal topics. You will also notice every worker exposes the same REST API on port A083. That means you can send connector management requests to any worker in the cluster, and because the configuration is shared through Kafka, every worker has a consistent view of the system. Let's look at the distributed worker configuration file. The first setting tells the worker how to connect to the Kafka cluster using the Bootstrap servers. Next is the group ID. This is one of the most important settings in distributed mode. Every worker that belongs to the same Connect cluster must use exactly the same group ID. That's how they discover each other and coordinate their work. We then specify 3 internal topics for storing connector configuration, sort offsets, and runtime status. Finally, we configure a replication factor of 3 for each of these topics. In production, this helps ensure the metadata remain available even if a broker goes offline. There are 3 settings you should always pay attention to when configuring a distributed cluster. First is the group ID. Every worker in the cluster must use the same value. If one worker uses a different group ID, it simply creates a completely separate Connect cluster. Second are the internal topics. These topics hold all of the shared state that allow workers to coordinate with one another. Finally, use a replication factor of 3 whenever possible. Since this topic contains the cluster metadata, protecting them against broker failure is extremely important. Kafka Connect creates 3 internal topics, and each one has a specific responsibility. The connect-config topic stores connector and task configurations. Since only the latest configuration matters, it's configured as a compacted topic with a single partition. The connect-offsets topic stores the progress of source connectors. This topic usually has many more partitions because lots of source tasks may be updating offsets simultaneously. Finally, the connect status topic stores the health and execution status of connector and task. This information is used for monitoring and coordination across the cluster. Together, these 3 topics provide all the shared state needed for distributed Kafka Connect. Although Kafka Connect can automatically create these internal topics, it's generally better to create them yourself in production. Doing so gives you full control over the replication factor, partition count, and topic configuration. Notice that all 3 topics use the cleanup policy set to compact. Log compaction ensures Kafka keeps only the latest value for each key, which is exactly what we want for configurations, offsets, and status information. You also notice the number of partitions is different for each topic. The configuration topic only needs a single partition because the connector configurations change infrequently. The offset topic has many more partitions to support higher write throughput, while the status topic sits somewhere in between. Once the configuration file is ready, starting the first worker is very straightforward. Simply execute the connect-distributed.sh script and provide the distributed worker configuration file. Unlike standalone mode, notice that we don't specify any connector configuration files on the command line. The worker simply starts and waits for connectors to be deployed through the REST API. Adding more workers is just as simple. Each additional machine uses almost the same configuration file. Typically, the only setting that changes is the advertised REST hostname, so other systems know how to reach that worker. Because every worker uses the same group ID and the same internal topics, they automatically discover one another and form a single Kafka Connect cluster. There is no manual clustering process or additional coordination required. This diagram illustrates what happens behind the scenes when workers start. The first worker joins the Connect cluster and initially becomes the leader. As additional workers join, Kafka detects the membership changes and triggers a rebalance. The leader then calculates how connected tasks should be distributed and assigns work across all available workers. This process uses Kafka Consumer Group Protocol, so task assignment and rebalancing happen automatically. If a worker later joins or leaves the cluster, another rebalance occurs and the workload is redistributed. Once your workers are running, it's a good idea to verify the cluster is healthy. You can send a simple GET request to the REST API on any worker. If everything is working correctly, the worker responds with information such as the Kafka Connect version, commit ID, and the Kafka cluster ID. Receiving this response confirms that the worker is running and communicating with the Kafka cluster. Now let's deploy our first connector. Instead of passing configuration files during startup, we send a post request to the Connect REST API with the connector configuration in JSON format. The worker receives this request, stores the connector configuration inside the connect-config topic, and the entire cluster immediately becomes aware of the new connector. Kafka Connect then creates the required tasks and distributes them automatically across the available workers. After deployment, it's useful to verify the connector is running successfully. A simple GET request to the connector status endpoint returns the current state of both the connector and its task. You will also see which worker is currently responsible for running each task. This makes it easy to troubleshoot problems and understand how work is distributed throughout the cluster. When deploying Kafka Connect in production, there are several best practices worth following. Start with at least 3 workers so the cluster can tolerate failures while maintaining availability. Give each worker sufficient memory, typically 4 GB of heap or more depending on your workload. It's also recommended to run workers on separate machines or containers and ideally across different availability zones to improve resilience against infrastructure failures. Network configuration is equally important. Every worker must be able to communicate with every Kafka broker, and the REST API should be accessible for connector management. In larger deployments, many teams place a load balancer in front of the workers to simplify access. Monitoring should also be part of your production setup. Make sure to keep an eye on connector health, task failures, internal topics, activity, and JVM metrics so that issues can be detected before they impact your data pipelines. Protect the REST API by enabling authentication and limiting access to trusted users. Secure communication between workers and Kafka using SSL whenever possible. The internal topics should also be protected using Kafka ACLs since they contain important cluster metadata. And finally, connector configuration often contain credentials for external systems, so make sure those secrets are stored and managed securely. Let's summarize what we have covered in this lesson. Distributed mode allows multiple Kafka Connect workers to operate together as a single cluster with shared state. Unlike standalone mode, connectors are deployed through the REST API rather than local configuration files. The 3 internal topics store connector configurations, source offsets, and runtime status, allowing every worker to stay synchronized. Kafka Connect automatically handles task assignment, fault tolerance, and rebalancing whenever workers join or leave the cluster. And for production environment, it's recommended to use at least 3 workers along with highly replicated internal topics to ensure a resilient and highly available deployment. In the next lesson, we'll look at plugin path and learn how to install additional connector jars so Kafka Connect can work with many different external systems.